Lesson 3.2, Task 2. Interpret slope as rate of change. A rate of change is a ratio of the amount of change in the dependent variable, your dependent variable, remember, is your y value, to the amount of change in the independent variable, and your independent variable is your x. It can be determined by calculating the slope of the line that represents the linear relationship between the variables. In a purely mathematical graph, the slope is just a ratio of the change in y, the rise, to the change in x, the run. There are no physical measurements involved. In a real-world graph, however, the variables do have associated units of measurement. This means that the unit of measurement for the rate of change is a ratio of the unit of measurement in the dependent variable to the unit of measurement in the independent variable. So again, remember, dependent variable is your y's and your independent variable is your x. That's important to remember. All right, so consider a car traveling at a constant speed. So here you can see this one is, it has 12 gallons of gas left, and it says that it's 45 miles, I guess, to their destination. Here it says they have 5 gallons of gas left, and it's 255 miles to their destination. The graph shows the relationship between the gasoline left in the tank and the distance traveled. All right, so you can see here these points come from the information given. We were given 12 gallons of gas and 45 miles. So distance traveled. So I guess that's the distance traveled instead of the distance to where they're going. Most road signs tell you how much further you have to get somewhere. I guess because this is just a math problem, it's telling you how far you've been. So we've got 45 is our x, that's our independent variable, and 12 is dependent. The amount of gas left depends on how far you've traveled. All right, so this other point comes from the second picture here, 5 gallons of gas left and 255 miles. So that's the distance traveled, and you can see that gas is going down. You have less gas after you've traveled more miles, which makes sense. All right, let's see what the questions ask us. All right, again here, this is gallons left, okay? And this is distance traveled in miles. So it says the rise between the 2 points is, so from here to here, we go from 12 down to 5, so that would be -7. And that's your difference of y's. All right, the rise represents a decrease in the amount of gasoline left. The units associated with the rise are gallons of gas. All right, complete the sentence. The run between the 2 points is, all right, we are going from 45 to 255. So if you take 45 away from that, that's 210. And that's your difference in x's. So it says choose the words to complete the sentence. This run represents an increase in the distance traveled. The units associated with the run are in miles. Choose the words to complete the sentences. The slope represents an increase or decrease of 1 gallon of gas. So it's going to be a decrease of gasoline for every, let's see, it's going to be, I think it's 30 miles because we're going to do 210. So we got difference of y's over difference of x's. Let's take that and divide it out. So you go down 1 gallon of gas for every 30 miles traveled. If you put that in, you can do -7 divided by 210. and that gives you negative 1/30. So that represents the 1 gallon of gas for every 30 miles traveled. So the units associated with the slope are gallons per mile. What was the other choice? Miles per gallon. It's gallons per mile. All right, that's all for task 2. If you have any questions, let me know. Lesson 3.2, task 3. Calculate slope. The slope of a line can be calculated if the coordinates of 2 points on the line are known or if the coordinates of 2 points can be identified from a graph of the line. All right, so here is the slope formula. We know the slope formula is rise over run. Remember your rise, that's your y values. Your run horizontally, that's your x values. Rise comes from the y's because you can see here that your rise is your vertical movement and your run is your horizontal movement. So again, the rise is your y2 minus y1, and the run is the x2 minus x1. So your slope formula is rise over run, so difference of y's over difference of x's. Now it does make a difference on make sure that your points are entered in the same order. So that means if you do y2 minus y1, you have to do x2 minus x1. If you do y1 minus y2, then you have to do x1 minus x2. So you'd have to use the same order for the ordered pairs. So it says for any 2 points, x1, y1, and x2, y2 on the graph of a line, the slope m of the line can be calculated using the formula. All right, and the formula is easy, again, if you just make sure that when you have 2 ordered pairs, you use them in the same order. All right, see here you can see x1 and y2. This is your x and y from your first point, and this is x2 minus y2, so your x and y from your second point. All right, use the labeled points on the line shown to find the slope of the line. All right, so for this one, let's see if I can get my pen here to write. So for this one, we can label this as x1 and y1, and this is x2 and y2. All right, so I'm just getting used to this new pen here. So let's do y2, which is 5, minus y1. And that's going to be over x2, which is 4, minus x1, which is negative 3. All right, so we've got 5 minus negative 6, so 5 plus 6. So that's going to be 11. And 4 minus a negative 3, so 4 plus 3 is 7. So 11 over 7. All right, so you can see here, it says use the slope formula, and they did the same thing. They labeled this as x1, y1, and this is x2, y2. And then they did 5 minus negative 6 over 4 minus negative 3, and they also got 11 over 7. All right, so it says suppose that the slope formula was used with x1, y1 equals 4, 5, and x2, y2 is negative 3, negative 6 instead. Choose the phrase to complete the sentence. So all they did was label the points opposite, but the same result should happen. You just have your numbers in the different order. So it says the number produced by the slope formula would be the same as the number produced from the original calculation. So if you plug it in correctly, you would still get the same answer. Is it important for the coordinates of the 2 points to be subtracted in the same order? And the answer to that is yes, because if you switch the order, then you would get an opposite sign or a different number for one that you should not get. So it says, how is this indicated in the slope formula? What happens if the subtractions are done this way? All right, so if you did the subtractions If you did not follow the order of the formula, you would get the wrong answer. All right, that's all for task 3. If you have any questions, let me know.